today's class. So do well to this channel so as for you to be notified whenever any video is uploaded. So in this class, we start from where we stopped in the last class. We were looking at some standard derivatives, and of course we stop at the fifth one, which is the derivative of exponential x. Now I will just add some other derivatives to it before we move to the next thing. So today, from where we start, let's see number 6, some standard derivative. So derivative of log x. Derivative of log x. That's natural log. And that is equal to 1 over x. Tan x. Derivative of tan x. This gives us sec square x. We have derivative of cot x. So this gives us minus cosec square x. Some rules of differentiation. So the number one rule of differentiation that we need to know is sum and differential. Sum and difference rule. So from the word sum and differential, it's just you have addition and subtraction. So any function that is of the form y equals to u plus v, where u and v are both function of x. So the derivative of y with respect to x, dy dx, will simply be du dx plus dv dx. And in the same way, if the function is different, that is subtraction, that is y equals to u minus v. In the same way, u and v here are both function of x. Our dy dx as well will be du dx minus dv dx. And sometimes the two signs might be joined together in a function. So let's look at an example here. For instance, example we have differentiate with respect to x, y equals to 3s cubed plus 4s squared minus 3x plus 5. So you have this function, and of course we have both sum and difference together here. So when we differentiate term by term here, then we add and subtract. So derivative dy dx here will give us d dx of 4s squared minus d dx of 3x, then plus d dx of 5. So when we differentiate this now, don't forget that the power and the coefficient multiply. The power and the coefficient multiply, then you minus 1 from the power. So 3 times 3, we have 9. So this becomes 9x squared, then plus the same thing here. Power and the coefficient multiply, then you minus 1 from the power because we are differentiating. So we have 2 times 4, that's 8. Then x raised to power 2 minus 1, that's x raised to power 1. Then minus differentiate 3x. Of course, the power here is 1 times 3, that's 3x. Then you have 1 minus 1, that becomes 0. Then plus, don't forget that derivative of a constant is 0. So 5 here is a constant, and that's 0. And therefore we have, finally, you can write the answer and say this is 9x squared plus 8x minus, of course, x raised to power 0, that's 1, minus 3. So this is our derivative of y with respect to x. We've applied this rule of differentiation. So it's a very simple rule. The number 1 rule there is a very simple rule. You just differentiate term by term and you add where you need to add, you subtract where you need to subtract. So the number 2 rule for today is product rule. We look at product rule. So from the word product, that's multiplication there. So when we have any function of the form y equals to uv, you see u and v here multiplied. So u is a function of x, v is also a function of x, and we want to differentiate y with respect to x. So the formula here is dy dx is equals to u dv dx plus v du dx. So this formula is applicable for product function. So this formula is what is called product rule. For example here, given that y equals to 2x plus 1 and multiply by 2x squared plus 2. So looking at this, you will see that these two functions are both functions of x, and they multiply, because in mathematics, when two brackets multiply, when two brackets are beside each other, it's the same thing as they multiply each other. So we can say let our u be the first bracket and let our v be the second bracket. So we can label this as u and we can label this as v. So therefore we now have it in the form of y equals to uv. And by the time you apply the formula, from this formula now, we have u dv dx plus v du dx. Now look at it very well. So we have the y dx will now become here. So our derivative of this function now will now be u. So this is your u now. We write u first. That's 2x plus 1. Then the v dx. Don't forget that this is our v now. So we now have d dx of our v. That is 2x squared plus 2. So we have written u dv dx now. Then plus on the formula we have plus v dv dx. So we write v now. We have our v as 2x squared plus 2. That's our v. Then we write the u dx. And this is u. That means d dx of u. And our u is 2x plus 1. So by the time we simplify this now, this one becomes, we have 2x plus 1. Then by the time we differentiate this, once you know that method of differentiation, it's very easy. We differentiate 2x squared, 2 multiply 2, then minus 1 from the power. So 2 times 2 here, that's 4. That's x raised to power 2 minus 1, that's x raised to power 1, and that's x. Then plus derivative of 2, that's a constant, that's 0. So we have this here. Then plus, here now you have 2x squared plus 2. Then differentiate this as well. You know that the power here is 1, so 1 times 2, that's 2. And you know 1 minus 1, that's 0. X raised to power 0 is 1, so of course this is 2. 2x will give us 2 now. Then 1 will give us 0, so we only have 2 here. So by the time we now expand this, you know, 4x will expand this bracket, And when 4x multiply 2x, you have 8x squared, then plus 4x multiply 1, that's 4x. Also, the same way, you expand these two to multiply. We have 2 times 2x squared, that is 4x squared, then 2 times 2, that's 4. So you can now collect the like terms. The like term is this, you have s squared, bring all the s squared to one side, and this is 8s squared, this is 4s squared. When we add it together, that becomes 12s squared. So this will be equals to 12s squared. Then you only have one x, no other x, and that is 4x. So that is plus 4x, and that is plus 4. So simply, this is the derivative of our y equals to this. Let's look at another example. We have y equals to s squared sine x. Look at this function here. You see that it's also in form of product rule. Why? Because you have two terms multiplying here. You have s squared is a 10, sine x is a 10, and both functions are both function of x. Here now, of two functions of x, let's label this s squared as v, and let's label this sine x as v. So now we want to find the derivative of y with respect to x. Don't forget from the formula that we have the y dx will give us u dv dx plus v du dx. So we have labeled our u and we have labeled our v. So therefore we can just substitute here now and say u, that's s squared, then dv dx. So d dx of sine x now, then plus v, our v is sine x, so that's sine x, then d du dx means d dx of s squared. So we have d dx of s squared, that's our u. Then by the time we simplify, we have s squared. Then when you differentiate sine x, d dx of sine x, when you differentiate sine x, and that gives us cos x. So this is cos x. Then plus, we have our sine x. Then differentiate s squared. You know that this will be 2x. Then by the time we simplify, we now have s squared cos x plus 2x sine x. So this is our derivative of y equals to s squared sine x using product rule. And do well to subscribe to this channel so that you'll be aware of our next video. By God's grace, for the next video we look at the third rule of derivative, which is quotient rule. Thank you for listening. We say bye for now.